Okay, so we're going to look at 9-2 today. I guess I should get out my pen, so that would be a little helpful. I could write in blood, shall I? Can I write in freshman blood? How about Omar's brother? No, I like your brother. I like your brother. He is. Huh? Oh yeah, that's right, he is. I forgot he is. Okay, so we're going to look at sorry, I got off topic. We're going to look at arithmetic sequences and then partial sums of arithmetic sequences. I'm losing my voice. All right, so if you recall from algebra, well, this looks a little different. I was going to say, yeah, this looks a little different. An arithmetic sequence has the form of D, which is your common difference. So D is your common difference, times N, which is the position that, like if you're trying to find the 150th term. And then plus C, and C is found, which is different. I think in Algebra 1, 2, you had A sub 1 plus N minus 2 times a common difference, right? Remember that? All right, so this is slightly different. You could still use that if you wanted to. Depends what you have. But C is found by taking A sub 1 minus D. So, yesterday you did a little guessing and checking, right, with your patterns. So, if you know it's arithmetic, and how do you know if it's arithmetic? How can you tell by looking at a sequence? If it has a common difference of addition or subtraction, right? And so then if you know this, which again I won't give that to you on your test, but you have on your quiz coming up, you have use of notes, don't you? Better learn it by test time, okay? So I won't give you this, and I won't give you this. So learn it. Those are helpful tools. So we're going to find the equation of the nth term, and that's supposed to be of an arithmetic sequence. So let's look at what they gave us. So they've given us A sub 1, which is the first term, and they've given us the common difference. We have to come up with the equation. So can't I use my shortcut? Right? With my shortcut, if I use my A sub n, which is what I'm trying to find, dn plus c. I know my common difference is 3. I'm going to leave the n alone because that's going to be part of it. Do I know c? No. So that's the first thing I have to do is find c. So remember, c is equal to a sub 1 plus d. Do I know those? Yep, a sub 1 is 2, and my common difference is 3. So isn't it minus? Oh, thank you. Good thing you're on the ball. And I have correction tape. Kelsey, are you counting? Okay, just check that. You are right, it is minus. For the quarter. Oh, okay, that's good. It's not the day. All right, so doesn't C become -1? So then your next step is just to replace A sub n is equal to 3 is my common difference, n, and then if C is -1, I put -1. And we're going to check it. If I were to just take my first term and add 3, because since it's positive, I know I'm adding 3, my sequence would look like this. 2, what's 2 plus 3? 5, what's 5 plus 3? 8, what's 8 plus 3? 11, dot, 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 right? And it would continue on that way. So let's plug in. Do I plug in 2 in for n? What do I plug in for n? This is 1, because it's the first term in the position, right? So what's 1 times 3? 3 minus 1 is 2. It worked, right? We'll try it on one other thing. So this is the second term of the sequence. So what's 3 times 2? 6 minus 1 is 5. Does our equation work? Yeah. Yep. So on to the next one. I want you to do that one on your own, because it's just like the first one. Do you agree? Let's test it. So this is the first term in the sequence. So 2 times 1 is 2 plus 198. You do get 200. This is the second term in the sequence. 2 times 2 is 4. 4 plus 198 is 202. Okay? All right. Then this one's slightly different. Right? Have they given me a sub 1? No. Have they given me D? No. Okay. So we're going to take step 1. If you're given 2 terms out of the sequence, but you know it's an arithmetic sequence, okay, the first thing you're going to do is take the difference between 13 and 4. So you've got 13 minus 4 is equal to 9. Right? So what that implies is that a sub 13 is equal to a sub 4 plus, I'll take this difference of 9 times d. So this one, if I were you, I would star it because it's an exception. It's not your normal thing. So we took the difference between our terms, 4th term and 13th term. I got 9. I took the further out of the 2 terms, a sub 13, and I put it here. And so if I knew what a sub 4 was, I would take 9 terms, right? Because I have 9 terms between the 2. And when I multiply them by the common difference and add that to that term, would that be how I would get a sub 13? Question.
How do you notice?
Because I'm trying to figure out how many terms are in between those two, so I'll always take the bigger minus the smaller. Because that tells me how many common differences I would be adding between those two. And we'll check it to make sure that it works. All right, so that's step 1. Can I do anything with that right now? What can I do? Do I know a sub 13 and a sub 13 and a sub 4? So let's plug them in. So I'm going to replace a sub 13 with 65 equals, I'm going to replace a sub 4 with 20 plus 9d. Now, want to be able to solve for d. So subtract 20, I'll get 45 equals 9d, and divide by 9, what does d equal? 5. So I have a common difference of 5. So I can count backwards, couldn't I? So step 3, if I've got my first, my second, my third, and then my 4th term, dot, 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 right? I know that my 4th term is 20. And if I'm adding 5 going this way, what am I doing going to the left? Subtracting 5. So this one would be 15, the second term would be 10, and the first term would be 5. Right? So now I know that this is a sub 1. So now I know a sub 1, and I know d. What do I do next? I can find c, right? So step 4, c is equal to a sub 1 minus d. So I've got 5 minus 5, which is 0. Okay? So then step 5, we're going to plug into a sub n is equal to d times n plus c. So a sub n stays the same. My d is 5, right? Times the n plus my c is 0. Is that my final answer? Questions? Yep, we can actually add 0 and we know what it is, right? So 5n plus 0, move that up. That means our final answer, a sub n, is just 5 times n, and we're going to test it. First term of the sequence would give an n of 1, right? So what's 1 times 5? 5, right? And then second term would be 5 times 2 is 10, right? third. 3 times 5 is 15. 4 times 5 is 20. And then if we want to figure out if we get to 65, you can test it, right? So we'd have, count on your fingers, we got 9 in between, right? So the 4th is 20. The 5th is 25, 30, 35, 40, 45, 50, 55, 60, 65. Isn't that 9 common differences? Did it work? Yep. All right, so this one's the hardest one. You're going to want to study it. So definitely I would be starring that. All right, flip it. And, oh, by the way, it is on your test. Don't think it won't be. It is there. All right, then we're going to look at partial sums of arithmetic sequences. And so you know this. Oh, can't see. How about that? Where n is the number of terms that are in your sequence, a sub 1 is your first term, and a sub n is the last term. So if there's 10 terms in your sequence, that's the 10th term. We're going to talk about what happens when we have an infinite sequence. How do we deal with that? So example 2. So we're going to start off step 1 with our formula. The more times you write that formula, you're more likely to do what? You're more likely to remember it. So if I were doing your homework, I'd be writing it down each and every time. It'll imprint itself in your brain. So what is n? How many numbers do you have? 10. What is a sub 1? 1. What is a sub n? 19, the last term. Is that it? That's all I have to know, right? So all you're going to do is plug and chug. So I'm going to replace n with 10. And I guess this is s sub, and your n here becomes 10. I'm finding the sum of 10 terms. N is 10 over 2 plus 1 or times 1 plus 19. So that equals 5 times 20, which is what? 100. So the sum of those 10 terms is 100. If you want to, go check that on your calculator. You can add those up. Somebody check it. See if it works. It worked, right? Absolutely. Well, you could, but I'd be looking for you to do this. And it's highly possible that I will give you a first and a last number, and I'll put a dot, dot, dot in between, because he's asking, what's to stop me from just adding those up? Very good question. What happens is I'll give the pattern, and it might be, and it might tell you that there's 50 terms in the sequence, let's say, but I put a dot, dot, dot in the middle, and I don't give you all the terms in the sequence. You'd either have to write out all 50 terms, which most of you are less likely to do, although in a pinch in a test you could, right? I certainly would if I forgot the formula. And then you could get around it. But we'd like to know the formula for those situations where I don't want to have to add up a million terms. I mean, I seriously could do a million on you, couldn't I? Then you're not going to be writing all up. So do beware. Good question. All right, so example 3. Well, it's an obvious question. I'm glad you asked it though, because see, I follow the rules. I'm a rule follower. So I know you're a rule follower, but he's like, what's the quickest way to get there? I don't even have to memorize the formula. I'm just going to add them up. All right, so we're going to find the 150th partial sum of the arithmetic sequence. The reason why it's a partial sum is what kind of sequence is this? It's infinite. It does never end. So technically, there's no sum to the sequence, right? But there is what's called a partial sum. So highlight that. We are actually finding the partial sum. And the 150th is important, right? So we're just going to do the following steps. So step 1. we need to find a sub 1. What's that? So a sub 1 is 5, so that's easy. What else do we need to know in our formula? A sub n. We don't know that one though, do we? Did they give us the 150th term? No. But we could find it. Couldn't we find the pattern of the sequence? Didn't I teach you on the other side how to find the pattern of the sequence? Yay. So that's what we're going to do. We're going to find, for that pattern, aren't we going to need to know D, the common difference? What's the common difference? 11. What else do I have to know? C. So remember, C is equal to A sub 1 minus D. You got the minus in there, right? So isn't it 5 minus 11? So what is C? -6, right? So now, step 2, can't you write the equation? So A sub n is equal to what? It's dn, right? So d is 11. And then what goes here? Minus the 6. So there's our general formula. Using that formula, can we find the 150th term? So then that's step 3, is we're going to find 150th term. So A sub 150 equals 11 times 150 minus the 6. 11 times 150 is, yes it is, 1650 minus 6. So A sub 150 is equal to 1644. So now we have the first term and the last term, right? And we know how many terms are in the sequence, the partial sequence. How many? 150. So then we can use that formula. S sub 150 is equal to 150 divided by 2 times A sub 1, which we found to be 5, plus the last term, which is 1644. So what's half of 150? 75. And then add these together, we get 1649. And then that product is a large number. 123,675. So the partial sum of the first 150 terms is 123,675. Right? And there are instances where you don't need to know the whole sum of that sequence, but you just might need to know a partial.